Hello everyone, this is Wayne from Holtop. Today we are at Shanghai. We are having the China Refrigeration live show here, and for this part, we would like to introduce you about our new product, which is the Modular behind me, and that is the Smart Control Intelligent Fresh Air System. And that is this part for now. Later on, we are going to introduce you the details one by one, and please stay with us. Regarding our smart control and intelligent fresh air system, it is highly intelligent, which means it can be customized as per the building functions and design demand. This system integrates all the HVAC device and equipment inside this whole building into one united system, which means it is more modern and more intelligent, which you can use the central control to control and monitor all the HVAC devices inside your building. This system, the Smart Control Intelligent Fresh Air System, is especially suitable for buildings like the large hospital, which has different rooms, and different rooms have different demands and standards for the air quality. And in this building, you can see this is a new hospital, and it has several sectors, such as outpatient department and inpatient department and emergency department and administrative department and operational department. And each department has different standard and requirements for the air quality. So we built and we designed this system to help this building to maintain and to monitor their air quality by the smart system. Compared to the traditional HVAC design and HVAC system in a regular hospital, and this new smart fresh air system has 4 advantages. The first one is the air quality secure, which means the system has a clear design on the fresh air supplying and exhausting air system. These two systems are totally separate, which means the airflow route is separate to ensure there is no air contamination or air cross flow. Okay, so the second one is the air quality cleanliness, which means the smart system can monitor the air quality in each room, in individual room. For example, when this room has no one inside, this room, the fresh air system would be minimize the fresh air. But when someone or multiple people enter this room, the smart sensor would start the control and starting to supply more and more fresh air into this room. So the third one is low energy consumption, which means in this fresh air system, we have an energy recovery system to recover the circulation air and to lower the heat consumption during the fresh air cooling down in this process. And the fourth one is to integrate the whole fresh air system into a central control board, which you can monitor and track all the information in the central control cabinet. So inside, maybe in the reception hall or maybe in the control room, you can have all the data, the real-time data for each room. In the design of a smart control intelligent fresh air system, there are some things we should think about for different projects, and usually there are 4 aspects we need to think about. The first one is the airflow route, which means from the AHU that extract the fresh air from outside and how to send to each room and what are the steps. So the major principle is to send the fresh air to the clean area first, and then to the semi-contaminated area. The last is to the full contaminated area. And this is the major principle to design the fresh air flow route. in this smart system. And the second one is to identify the minimum fresh air for each room. As we introduced earlier, for example, we can preset the minimum fresh air for each room. For example, maybe in this room, there only normally are 2 people inside this room. And for the next room, maybe there are 5 or 10 people, which means in this room, they should have larger and more fresh air. So it is important to design the minimum and max air, fresh air for each room. So the third one is the ventilation operation time. As we know, in hospital, normally in China, the standard is 6 times air change per hour in hospital, which means the smart fresh air system should be should be operating 24 hours a day. But as we said before, when the smart system sensor, there is no one in the room, the fresh air can be working and operating in a minimum level. And you can use the other fresh air to other rooms where there are more people. So in this way, we can supply enough fresh air to each room, but in a very low energy consumption way. And the fourth one is the energy recovery we just said before. Because in hospital, the 100% recirculation air is not safe and secure, because there could be air cross-flow contamination. And for this reason, we have designed the energy recovery inside the smart fresh air system to circulate the exhausting air and the fresh air, which means when the fresh air was inhaled from outside, maybe at 35 centigrade, and the fresh air can mix with the circulation air at 25 centigrade. After the energy recovery, the fresh air could be lowered down maybe to 27 or 30 centigrade, and then the fresh air goes into the cooling coil. In this step, by the energy recovery, we can lower down the energy consumption up to 60%. And this is the 4 principles we have to consider during the design. In this part about the smart control intelligent fresh air system, I would like to show you the major parts for this system, which is in this catalog in here. So the first one we can see is from here, from the right to left. And the first one is the fresh air handling unit. The HU would bring the fresh air from outside and then go through a pressure transmitter. Next is the variable airflow modular. This modular is to sensor the parameters such as fresh air flow and the CO2 amount, and to sensor the temperature and to sensor the humidity. And from the fresh air goes through the HU, then sent into each room inside the hospital in this here, and then part of the fresh air will circulate and return to the exhausting air. Exhausting air, this unit, the purpose is to recycle and recover part of the energy from the recirculation air, and of course, in the same time to exhaust some of the air to the outside to ensure the room has correct and suitable amount of air changes. And on the left, on the right at this part, we can see the central control part, includes the PLC module and a smart control cabinet, where you can see, monitor, and trace all the fresh air and temperature, humidity, CO2, and other parameters in each room. By each room, we mean every room inside the hospital. And that is the powerful function of the smart control system in here. And for this part, I want to take one floor in the hospital as an example and to introduce to you how to design the air ductings in this system. From this layer, you can see there are two colors. The green one, we can see it as the air supplying ductings. You can see the green ductings was designed to cover all the rooms in this area, and the yellow one, which is shining, is the return air system. So the air ductings are covered all the room here, but as we introduced before, some rooms are used to be positive pressure, such as the reception hall, administrative department, or inpatient department. Those departments usually have a positive air pressure. And for some other rooms where there are air contamination, such as operation room or contaminated room, for these rooms, the air pressure should be negative, which means in those rooms, the air should not cross flow with other rooms and should not flow outside the rooms in order to, as a result, if the air in the negative pressure room go out and the air would contaminate other rooms, which is dangerous. So we have to consider the air pressure in each room during our design of the supply air ductings and exhausting air ductings system in this floor. And of course, I'm only taking this floor as an example. The principle is the same for all the floors. We have to consider the air cleanliness and room pressure and the minimum fresh air flow. That is how we design the air ductings in this part. In this part, I want to briefly introduce you about the ductings and HVAC design in this system. So please follow me at here. And in our modular, the first part is the exhausting air system, which is 1, 2, 3, 4, 5, 6. The 6 air handling unit, they are extracting the indoor air from the yellow ductings, and exhaust part of the indoor air to outside. And of course, before exhausting the air to outside, the exhausting air handling unit has the recycle energy recovery system to recover part of the indoor air to mix with the fresh air, which is used to cool down and reduce the energy consumption during the process of cooling the fresh air. And speaking of the energy recovery, which is this system, and here, 1, 2, 3, 4, 5, 6. These 6 units are used to recycle and to recover the energy from the exhaust AHU. And if you are curious about the media, and as we all know, the recovery system, the media is not chilled water or refrigerant. Actually, it's glycol. It is normally a widely used medium in this system. And from here, you can see there are 6 units of the energy recovery unit. They recover the circulation air and then send back to the fresh air handling unit. So the recycled air can mix with the fresh air and to reduce the energy consumption. And here, that is the chiller to supply the refrigerant and the gas and the liquid for the AHU. And this is the simple system of the smart fresh air system from here.